Now that we've got the hang of looking for lowest common denominators, the reason why we were doing that is because we're going to want to add rational expressions or subtract rational expressions. In order to do that, just like with all fractions or rational expressions, you have to have a common denominator. Well, as you remember in our example a while back, these two did not have a common denominator, but we found one, and the common denominator, or the lowest common denominator, was 18x squared. So if both denominators were 18x squared, then I can go ahead and add these two rational expressions. 6x squared. How do I ensure that this first denominator has an 18x squared in it? Well, I'm going to multiply it by a clever version of 1. And the clever version of 1 I'm going to choose is a 3 over a 3. Remember, I can multiply the number 1 to any fraction or rational expression and will not change its value. So I'm going to choose 3 over 3. And in doing so, this gives me 21 over 18x squared. So there's one of my 18x squareds. In the second rational expression, 2 over 9x, I need to think of what's my clever version of 1 such that my denominator is going to be 18x squared. And I'm going to multiply it by a 9x over a 9x. Whoops, not a 9x. That's going to give me 81. I don't want that. I want to multiply it by a 2x. 9x times 2x, there's my 18x squared. And on the numerator, 2 times 2x, which is a 4x. So now I have two equivalent expressions for my original rational expressions. So let's add these guys up. 21 over 18x squared plus 4x over 18x squared equals, denominators are the same, so I keep them, 18x squared. And the numerators, I add like terms, 21 plus 4x. There are no like terms, so I leave it in that form. So 21 plus 4x over 18x squared is my final solution to adding these two rational expressions. And in so doing this process, I had to use its lowest common denominator.